Good day, everyone. So for today's topic, I will be discussing about trigonometric identities. Okay, so I just want to remind that we are now in chapter 8. Okay, so for this chapter 8 po, we will talk about the identity equation and conditional equation as well as the fundamental trigonometric identities. Okay, and we will actually know how to simplify trigonometric identities and also how to prove, okay, how to prove trigonometric identities as well, okay. But before we proceed on that, um, let's define first the identity and conditional equations, okay. So it's stated here that when we say identity, okay, so an identity is actually referring to an equation that is true for all valid replacements of the variable, okay. So here in identity po, okay, so we're talking about equation. So if your equation is true, okay, for all valid replacements, say for example, you have a certain values for the variable po you have in the equation po, then that must be considered as an identity equation, okay. For instance, say for example, I have here x squared plus y squared, okay, equals r squared. We all know that is a Pythagorean theorem, isn't it? So the x plus 3x, we all know that that is actually equal to 4x, okay. So 3x plus 3x equals 4x is true actually for all x, okay. And if your y over y is equal to 1, then therefore it is said to be true for all y, okay, wherein y should not be equal to 0, okay. So this statement is actually pertaining to the identity itself, okay. Identity na kung saan po the condition is actually true, wherein y over y is actually equal to 1, okay. So that's the basic concept of identity. While in addition, on the other hand, when we say conditional equation po, conditional equation, there will be the so-called condition wherein, say for example, you have the given equation there, okay, and it talks about the true statement, okay, if there's a corresponding value for that, okay. So it's something like there's a condition for the equation for it is said to be true, okay. So in addition, the conditional equation is actually referring to the statement that is true on condition that the variable is replaced with the correct value, okay. So this will be now the values that you have if you're going to replace that, and if it suits to the correct answer, then therefore, okay, that will be considered as conditional equation, okay. So there's a condition. For instance, say for example, I have here x plus 5, okay. So in this statement, x plus 5 is equal to 11. We don't know if it is equal to 11 only, okay. And it's stated here this equation is actually true if your x is equal to 6, because if you're going to substitute 6 here, 6 plus 5, you will be having 11. So this equation po will be true if there will be a condition, okay, wherein x equals 6, okay. So if your x is equal to 5, okay, so it's not equal to that. It's not true, that statement, right? So if it this is true, this equation is true if there will be a condition wherein x equals 6. And it's a fact that if you're going to add 6 plus 5, you will be having 11, okay? So that will be the concept or the basic concept of conditional equation po. Okay? Another example. Say for example, I have your 3x equals 15. So, kailan po ito magiging true, itong equation na to? If your x, okay, so there will be the word if there, okay, that is actually referring to the condition. If your x is equal to 5. Since 3 times 5, if you're going to plug in x here, that is actually equal to 15, okay? So that will be the example, okay? Example of conditional equation. Another one for you to understand is actually here for the third one. The x squared equals 4x. So, kailan po ito magto-true? If you have a condition wherein your x is equal to 0, and another one for the x value po, which is 4. Okay, so it can be both, something like 0 and 4. So if your x is actually equal to 0 and 4, then therefore this statement is true. Okay, this is correct, and it is actually aligned with the conditional equation. Okay, so that will be the basic concept of that. So now let's proceed here to the fundamental trigonometric identities. Okay, so it's stated here that a trigonometric identity is an identity that involves trigonometric functions of one or more variables. So it actually involves the six trigonometric functions po. So what are those? That will be the sine theta, the cosine, the tangent, the cosecant, secant, and cotangent. Okay? And we have here actually the following identities also. And for this one, I will be giving you the equation po for the identities po in reciprocal, in terms of reciprocal identities, quotient identities as well, the Pythagorean identities, which follow each solution is true for all values of central angle for which both sides are defined. Okay, so the reciprocal identities were stated for functions of angles in this section. For instance, say for example, I have here a reciprocal identities. Okay, so I want you to keep this one in your mind because this is something like important. Okay, so if you have their sine theta, okay, always remember that that is actually equivalent to 1 over cosecant theta. Okay, that is for the reciprocal identities. Okay, while for the cosine theta, okay, that is actually equal to 1 all over secant theta. As you can see, that is actually the reciprocal of that certain trigonometric function po. Okay, so we have here also the tangent theta, which is actually equivalent to cotangent theta. So since we're talking about reciprocal, we should say that if we are actually finding for the cosecant theta, okay, we should say that that is actually reciprocal of sine theta as well. Thus, we should say that if you have here cosecant theta, that is actually equivalent to 1 all over sine theta. Okay, as you can see here, nagbaliktad lang po yung um, trigonometric function po natin. Okay, as well as here, for the second one, you have here secant, okay, theta. Say for example, you are looking for the secant theta. So that is actually equivalent to 1 all over cosine theta. Okay? And if you're looking for the cotangent naman po, since we're talking about reciprocal naman po, okay? So that is actually equal to 1 all over tangent theta. Okay? So I want you to write this one on your notebook because this is something like important. Okay? For identity, reciprocal identity. And now let's proceed to the quotient identities. So I have here only two quotient identities wherein it pertains to the tangent and cotangent. Okay, so if you have here tangent theta, that is actually equivalent to sine theta, as what I have told you last meeting, right? That tangent theta is actually equivalent to sine theta all over cosine theta. Okay, so as what I said po last meeting, if you are looking for the cotangent naman po, you just need to what? To get the reciprocal of this given value po. Thus, we should say that if you're looking for the cotangent theta, that is actually equivalent to cosine theta all over sine theta. Okay, so that is for the quotient identity. Okay, so I want you to write that one in your on your notebook po. And if we are talking about Pythagorean identities naman po, always keep in mind that if we have your sine, if you're going to add sine squared theta and cosine squared theta, automatically that is actually equivalent to 1. Again, if you're going to add sine squared theta to cosine squared theta, that is actually equivalent to 1 po. Okay, so through this concept as well, okay, we will come up with this idea wherein if you're going to add plus 1, okay, to the tangent square theta, so you have your tangent square theta plus 1, okay, that is actually equivalent to secant square theta, okay, always remember that. And another one, if you're going to add 1 into the cotangent squared theta, then you will come up with the cosecant squared theta. Okay, so that is for the Pythagorean identities naman po. Okay? So I want you to, to memorize, or something like you have to familiarize with that concept for the reciprocal identities, quotient identities, Pythagorean identities, for you to be able to, easily solve. Say, for example, you are simplifying trigonometric identities, or you're actually proving trigonometric identities. Okay? So let us prove, okay, for the reciprocal identities. Okay, so we have here actually the solution, okay, for proving the reciprocal identities. Okay, so using the previous definition earlier in the previous slide, okay, stated here that the cosecant theta is actually equivalent to 1 over y, right? Wherein your radius will be served as your 1 po, right? And we all know that cosecant theta is actually equal to 1 over y. And we all know that y is actually equal to sine theta, as what I have that discussed to you, right? Last meeting. So therefore, if you're going to, substitute that one, so using this, manipulation, the cosecant theta is actually equal to 1 over sine theta. So this is actually the proof on how are we going to come up with 1 over sine theta for cosecant theta, right? Diba sabi ko nga sa previous slide, cosecant theta is actually equal to 1 over sine theta. So using this one, 1 over y, okay, using the Cartesian coordinate system wherein the radius is actually equal to 1, and you have there the x and y, wherein x is actually pertaining to the cosine theta and y is for the sine theta. Okay, so that will be the proof. That will be the proof. Okay, and for the secant, this will be the ano po, the proof. Okay, so secant theta is actually equal to 1 over x, as we all know, right? And we all know x is for cosine theta. Therefore, if you're going to substitute that one there, you will be having 1 over cosine theta. That's why secant theta is actually equal to 1 over cosine theta. Okay? And for the cotangent theta naman po, we all know that is actually equivalent to x over y, isn't it? So again, if we're going to substitute this one, since we have here y, your y is actually equivalent to what? That is actually equivalent to y over x, isn't it? So if you're going to simplify this one, get the reciprocal of that, so you will be having 1 all over tangent theta. Okay, always remember the opposite of that will be cotangent. Okay, tangent is for sine theta all over cosine theta, and for the cotangent opposed with the tangent, which is cosine theta all over sine theta. Okay, so this will be the proof, okay, on how are we going to come up with the reciprocal identities. Okay, so now let's simplify now trigonometric identities, since you already know now the identities, okay, for reciprocal, quotient, and Pythagorean. You can actually apply now that one, okay? For instance, we have here example number 1. So let us simplify this expression po, wherein we have here sine raised to 4 theta minus cosine raised to 4 theta all over sine theta minus cosine theta. Okay, so how are we going to simplify this expression into simplest form using the identities that we have discussed in the previous slide? Okay, so all you have to do here, as you can see here, we can actually factor the numerator, okay, for us, to simplify more this expression. So we all know that if we're going to multiply that one, okay, if we're going to multiply sine squared theta minus cosine squared theta, so this is something like sum and difference, okay, sum of difference of binomial. As you can see here, sine raised to 4 theta, that will be served as your first term, and this will be the second term that you have. So for the rule po, if you still remember the sum and difference, so this is actually equivalent to sine raised to 2 theta, since we have here 4, so we need to divide that one, okay? Wherein, if you're going to add sine raised to 2 to, multiply sine raised to 2 theta to sine raised to 2 theta, you will be having sine raised to 4 theta, isn't it? And if you're going to simplify this one, the middle term will become 0, right? And here for the last term, if you're going to multiply this one, the last term, okay, still remember the FOIL method. So negative cosine 2 theta times positive cosine 2 theta, that is actually equivalent to negative cosine 4 theta. So this one, this factor, okay, is actually equivalent to this one. Okay, so for instance, nag-factor lang po muna tayo dito. Okay? And we all know that sine squared theta, as what I have discussed to you po kanina, ito pong sine square, if we're going to add, right, sine squared theta plus cosine squared theta, that is actually equivalent to 1, right? As what is stated in the, ano po, in the Pythagorean identities po, isn't it? That is equally equivalent to 1. This one is not equivalent to 1 because we have here minus, okay? So for the next step, okay, so let's say that this one is equal to 1. That's why we have here 1. Ang natira po is ito po. Okay, all over sine theta minus cosine theta. Copy lang po. And then ito po, as you can see, sine squared theta minus cosine squared theta, we can actually factor out also this one, right? So this is something like sum and difference lang din po as dito po sa ating ginawa sa first step po. So ganun lang din po iyon, but this time around, your exponent is actually equal to 2. So if you're going to factor out that one, that is actually equivalent to sine theta minus cosine theta times the quantity of sine theta plus cosine theta. Okay, so this one in your numerator, equivalent po siya dito po. Okay, finactor out lang po. And then, copy the denominator. As you can see here, we have the same, right? The same sine theta for the first term and second term. So we can actually cancel out that one. Okay, at ang matitira po will be sine theta plus cosine theta. And that will be now the final answer. Okay? So we have here the simplest form of this expression, which is sine theta plus cosine theta. Okay? So that's how are we going to simplify trigonometric identities. Okay? I hope nakuha po yung process. Factor out lang po. Okay? Factor out lang ng factor out hanggang sa ma-simplify po yung expression into simplest form. Okay? Okay, so for you to understand more, let's have another example. So we have here the given expression, okay? So we are asked to simplify, okay? So we have here secant squared theta minus tangent squared theta all over sine theta, okay? So we all know in the identity po na ang secant is squared po sa Pythagorean, right? Ang secant squared po ay equal sa tangent squared theta plus 1, right? So as you can see here, we have here this one, okay? Ito po, right? Yung kanina po sa slide, ang secant square ay equivalent to tangent square theta plus 1. So we can actually, substitute that one, that value into secant squared theta po, okay? And remain po itong tangent squared kasi nga po we are aiming for the same variable, right? So wag na po natin itong i-simplify, okay? So, copy lang po. And then, we'll know that your, this one, okay, if you're going to simplify that one, tangent squared minus tangent squared, of course, that is actually equivalent to 0 na po, right? So, cancel out na po iyon at matitira po is yung 1. That's why we have here 1 all over sine theta. Copy lang po. And we'll know in identity po na ang 1 all over sine theta po, right, sa reciprocal identity kanina, na ang equal po nun will be cosecant theta. Therefore, the answer will be cosecant theta. Okay? Always remember the identities. That's important. Okay? So for this one, for this given po na expression, if we're going to simplify that one, you will come up with the cosecant theta. Okay? Since cosecant theta is actually equivalent to 1 all over sine theta. Okay? So one of the keys po to answer this one is, of course, you have to familiarize, okay, or you should memorize, okay, as a practical way, okay, the reciprocal identities, the quotient identities, the Pythagorean identities, okay, or identities as in general, okay? So now let's proceed on proving po, okay, how to prove trigonometric identities. So let's have here an example. Say for example, we have here the given sine theta, quantity sine theta plus cosine theta square. Okay? So let us verify the identity na kung saan ito po, itong sine theta plus cosine theta po, squared, is actually equal daw po dito, which is 1 plus 2 sine theta times cosine theta. So paano po natin ito mapuprove na ito po ay same po dito? Okay? So using the identities again, you can actually prove that. Okay? So ang aim po natin is to make this sine theta plus cosine theta squared like this, okay, which is 1 plus 2 sine theta cosine theta. How to do that? So let's focus here in this expressions po, okay? So we have our sine theta plus cosine theta squared. So all you have to do here is you have to simplify. So your sine theta will be served as your first term po, and your cosine theta will be served as your second term. Okay, so this will be the first and the second term. So this is something like, simplifying square binomial. So all you have to do here, okay, so you can actually use FOIL method, or you can actually, follow the rules wherein you have to square the first term, multiply the first and the second, and multiply it by 2 for the middle term, and then square the last term. Okay, so to do so, square the first term. So you will be having here sine theta square plus for the middle term po, ito po. So you have to multiply yung first at second at i-multiply always by 2 since this is ano po, is square, right? Your exponent is 2. Therefore, you will be having here sine theta times cosine theta, then times it by 2. You will be having sine 2 sine theta times cosine theta. And for the last term, you have to square po the last or the second term, which is cosine theta. So you will be having here cosine theta squared. Okay, so in simplifying that one, okay, you will be having like this. So let us combine this sine squared theta. Okay, so if you're going to simplify this one, this will be now equal to sine squared theta plus, okay, nilipat ko lang po dito, plus cosine squared theta plus, copy lang po ito, i-multiply na natin, you will be having 2 sine theta times cosine theta. And we all know again that sine squared theta plus cosine squared theta is actually equal to 1, isn't it? Always remember that. If you're going to add the square of the sine, okay, square of sine theta and the square po of the cosine theta po, you will be having 1, okay? So this one po is actually equal to 1 na plus, copy this one, yung middle term natin kanina, so you will be having plus 2 times sine theta, okay, times cosine theta po. Okay, so therefore, na-prove na po natin using this process, using the identity din po, na itong sine theta plus cosine theta square, quantity sine theta plus cosine theta square, is equivalent to 1 plus 2 times sine theta times cosine theta. Okay, so that will be the process on proving trigonometric identities. I hope nakuha po yan. Okay. So again, you just need to rely on the identities that I gave to you earlier in the previous slide po. Okay? So for you to understand more, let's have another example on proving trigonometric identities po. Okay, so say for example, we have here example number 2. So let us verify again the identity wherein your secant, okay, your secant square tangent po, I mean secant theta minus tangent theta square is actually equal to this statement po. Okay, this expression. Okay, so how to do that again? Okay, so do the same thing as what we did in the previous slide. So we are looking for this expression po, which is 1 minus sine theta all over 1 plus sine theta. So again, let's just simply simplify using FOIL method or the rules po itself. So let's use the rule po. So square the first term, ito po. So we have here secant square, okay, or secant theta square po. And then multiply the first and the second. So secant theta times negative, okay, negative tangent theta times by 2 always. Okay, that is for the middle term. Then you will be having negative 2 secant theta times tangent theta plus square po the last term or the second term. So we all know negative times negative is positive. That's why we have positive. And you will be having tangent square theta. Okay? And we all know we can actually, using the identity itself din po, your secant theta is actually equal to 1 over cosine theta, isn't it? So, the same lang din po siya, right? So, i-substitute lang po natin yung secant theta, that is 1 all over cosine theta square, okay? So, may square pa rin po, sinubstitute lang natin. Minus 2, okay, times your secant theta again is actually equivalent to 1 all over cosine theta, right? So, that is for the reciprocal identity, right? If still remember. So yung secant is for 1 all over cosine theta. That's why we have here this one. And for the tangent, right? Kanina po, we have here sine theta all over cosine theta, right? Yung tangent. Ito po yung equivalent niya. At yung cotangent naman, di ba, we have here cosine theta all over sine theta naman. So, but then this is tangent, then therefore you have here sine theta all over cosine theta. Plus, your tangent again, that is equivalent to that, then square of that. And you can actually simplify that one. So you have here 1 all over cosine theta square. So 1 times 1, you will be having here 1. Then cosine theta square, you will be having cosine square theta here. Okay? Minus. So you have here 2 times 1 times sine theta, numerator to numerator to numerator po. Then you will be having 2 sine theta. And we have your cosine theta times cosine theta in your denominator. I-simplify nyo po iyan. So you will be having cosine squared theta. So ganun lang po yon. Plus, ito po, simplify nyo po ito. So yung 2 po, mapupunta na po dito sa sine. So you will be having sine squared theta all over cosine squared theta. Okay? And since we have here the same denominator, which is cosine squared theta, we can now actually combine that one. And then, subtract and add the numerator. Okay? So you will be having here, pinag-isa ko na po dito, cosine squared theta. So you will be having here 1, okay? 1 minus, okay, as you can see here, 1 minus sine theta plus sine square theta. Okay, actually we have here this one. Okay po. So that will be the simplification po of this one. Okay, are you still with me? Let me know. All right. So again, we have here this one. Always remember may 2 po tayo dito, okay? Kasi po di pa natin nasisimplify. So there's a 2 here. Okay, so 1 minus 2 sine theta plus, okay, kinopya lang po natin. So there is 2 here plus sine theta, sine squared theta. Okay? So what's next? So we have here this one, 1 minus 2. Okay, meron po tayo ditong 2. 2 sine theta plus sine squared theta. Okay, so meron pong 2 dito. So we're gonna actually factor out this one. Okay, so you to factor out that one po, square the first term and square po the last term. Okay, and since this is minus po, so therefore the sign of this one po will be positive. I mean will be negative and negative, right? So if you're going to add negative and negative, you will be having negative rin, which is negative po dito sa middle term. Also remember, may 2 po dito, okay? 2 sine theta. So if you're going to simplify this one, the same lang po dito. At pwede rin po natin itong i-simplify. So this is something like sum and difference po, right? So we don't have here middle term. So we can actually rewrite this one as 1. So get the square of this and the square of this one po. So this is minus. So we don't have middle term, therefore that is positive and negative po para ma-cancel out yung gitna, right? So you have here the factor out. So we have here 1 minus sine theta times 1 plus sine theta. Okay? So as you can see here, we have the same mga terms. So you can actually cancel out that one. Okay? So cancel out 1 minus sine theta, then 1 minus sine theta in your denominator. Okay? And the result po will be 1 minus sine theta all over 1 plus sine theta. So we prove here that the secant theta minus tangent theta square, okay, quantity of that, is actually equivalent to 1 minus sine theta all over 1 plus sine theta. Okay, so that's how are we going to simplify trigonometric identities. Okay, that's how are we going to simplify and prove trigonometric identities. Okay, I think that this is only for today. And I hope you've learned something new po, especially with the concept of identity and also the conditional identity, how to simplify and how to prove also, okay, using the reciprocal identities we have, quotient identities, and the Pythagorean identities. Okay, so thank you for listening. Goodbye, everyone.